Well, what happens if the quadratic function is not in standard form? So, the first thing we did in this section is I introduced you to the general form of a quadratic, which is y equals ax squared plus bx plus c. But this is in general form, and general form doesn't tell us how to graph it. We need it to be in standard form, because the general form tells us nothing about the quadratic, or the graph of the quadratic. So we get sad, because we can't figure out what's happening. So, what we have to do to put it into standard form is complete the square. But first we're going to look at standard form, and we're going to convert it to general form. So let's imagine that we were given this and we had to convert to general form. And we may have to do this. So what we're going to do is we're just going to expand this out. So x plus 1 squared is just x plus 1 times x plus 1 minus 5. And if we expand that out, we have to expand out those terms, those binomials. We're going to get x squared plus x plus 1 minus 5. So we're going to get 2x squared plus 2x plus 2x plus 2 minus 3. We're going to get 2x squared plus 4x minus, for some reason I wrote a 3 here. I should have said this is still that 5 I'm carrying along. And what happens is this becomes minus 3. So there we have it. We've taken something in standard form and we've converted it to general form. Now, in the previous equation, the x plus 1 squared is a perfect square trinomial. So if we have x plus 1 squared, what that means is x plus 1 times x plus 1. When we FOIL that out, we would get x squared plus 2x plus 1. Down here, we have another binomial squared. So x plus 5 squared is the same as x plus 5 times x plus 5. If we were to expand this out, we would get this perfect square trinomial. Now let's look at these perfect square trinomials a little closer. How do we get this last term? How did we get 1 and 25? Well, what we did here is we took the number in the binomial and we squared it. So 1 times 1 is equal to 1. And down here, 5 times 5, 25. So this number here, 5, square it, we get 25. This number here, 1, square it, we get 1. So what about this number here and this number here? To get 2 and to get 10, what we did is we did 2 times 1. And 10, what we did is we went 2 times 5. And that's always true for perfect square trinomials. Is the number in the middle is this value times 2. This value times 2. Or we can look at it as the square root of the last number doubled. So the square root of 25 is 5. When we double that, we get 10. And these are properties of any perfect square trinomial. We're going to now try and create a perfect square trinomial. Only this time we're given the middle term. Now, if we look back here, we doubled it, took the square root of this number, and doubled it to get this value. If we work in reverse, what we have to do is take half of this term and then square it to get this value, to create a perfect square trinomial. So if we have x squared minus 8x, we need half of negative 8. So negative 8 divided by 2 is negative 4. And a good habit to get into, which is going to come very helpful afterwards, is just write down what that value is. Negative 4. Because now we take negative 4 and we square it, and this becomes 16. So what is the square binomial? Well, it's x minus 4 squared. So let's try the next one. What's half of 3? Now this is where we run into some difficulties. There is no number that's half of 3. We could say it's 1.5, but what we want to do is we want to work with a fraction. So it actually is not hard at all to take half of 3, because half of 3 is just 3 over 2. Now what's 3 over 2 squared? Well, this is just 9 over 4. So to create that perfect square trinomial, we would have to put 9 over 4. What is the square binomial then? Well, it just becomes x plus 3 over 2, all squared. And if we were to expand this out, we would get this value. Now, hopefully by now you've noticed why I want to keep track of this number. Because once I go to create the square binomial, it's just a matter of putting that number back in here. Putting that number back in here. Let's look at the last example. The only thing that's different about this last example is that there's a 2 in front of it. Now, here is the big thing, is we cannot create a perfect square trinomial. Let me repeat that. You cannot create a perfect square trinomial if there's a number in front of x. So what we have to do to create a perfect square trinomial is factor out the number. So we're going to factor out a 2, leaving us with x squared minus 5x. So we factored out 2 from both of those values. And now what we're going to do is we're just going to work inside the brackets. The 2 is going to come along for a ride. So we're going to have x squared minus 5x. And to complete the square in there, we'd have to take negative 5 and divide it by 2. And then square this value. So it would actually be plus 25 over 4. What's the square binomial? Well, it just becomes x minus 5 over 2 squared, but we can't forget that 2 that's coming along for the ride. So that's how we can create a perfect square trinomial. And the main purpose of completing the square is completing these, or creating these perfect square trinomials. So let's look at an actual example here. So what we're going to do now is we're going to complete the square on this equation to convert it to standard form. Right now it's in general form. So we do this the same way that we've been doing completing the square. The first thing we need to do is take our middle term, and your middle term is always going to be your linear variable, your variable with no exponent on it, or an exponent of 1, and we're going to take half of that term. So what is half of 20? Well, half of 20, of course, we can do that in our head, is just 10. And let's put a little square around 10. Because this is going to become x squared plus 20x. And to create that perfect square trinomial, we take 10, which is half of 20, and we square it. So 10 squared is 100. Now, here is the big but. If we put 100 into our equation, our original equation did not originally have 100. We can't just come along and throw 100 in there haphazardly, or we change the entire question. So if we're going to put positive 100 into our equation, we also have to put negative 100 into our equation. Because positive 100 and negative 100 are going to disappear, and we would get back to our original equation if we turn the record backwards, if we worked up. So we can't just add a number without adding the same number except negative. So now we want to create the perfect square trinomial. Which term do we want to put inside our trinomial? Well, of course, we always want to keep the positive term. We want to keep that positive 100. So we're going to put that positive 100 in brackets, and we're going to keep it aside. And now, we did put a negative 100 in, but we got to bring it along for the ride. Now, we have a perfect square trinomial. And what does this square trinomial, perfect square trinomial become? It just becomes x plus 10 squared minus 100. And let's look what we've done here. We've taken something in general form, and now we've put it in standard form. We can determine where the vertex is. We can determine the axis of symmetry. We can determine which way it opens. We can do everything that we need to graph this equation once we have completed the square.